At this point in the tutorial series, we know that Java is an object-oriented programming language. One trait that makes it an object-oriented programming language is that it supports polymorphism. Webster's dictionary defines polymorphism as the quality or state of existing in or assuming different forms. In the Java programming language, polymorphism occurs when an object of one type can take the form of an object of another type, and in doing so, the output of methods invoked on the object depends on the specific form or type the object being worked on is at that point. This concept may be confusing to some right off the bat, but I can assure you once this video is over you will have an understanding of polymorphism, as it is not as complex of a topic as you may think. As always, let's look at an example to get a better understanding. Here we have a class called vehicle. This class does not contain much. In fact, it only contains a toString method that returns a generic string of car make. In addition to the vehicle class, we have three additional classes that inherit from the vehicle class. There is the fast car class, the eco car class, and the hybrid car class. Notice all three of these classes have one method within them. This method is a toString method, and since these classes inherit from the vehicle class, which has a toString method itself, the toString method in each of the three classes is overriding the toString method of the vehicle class. Now let's create a main method in which we can utilize these classes and most importantly exercise polymorphism. Let's create a new class and call it car dealer. We can include the main method stub in this class. Within the main method, we will instantiate 4 objects from the vehicle class, and therefore these objects will be of the type vehicle. The names of these objects will be car1, car2, car3, and car4. Next, we will have car2 morph into an object of the fast car type by typing car2 equals new fast car. Similarly, we will have car3 morph into an object of the eco car type by typing car3 equals new eco car, and car4 morph into an object of the hybrid car type by typing car4 equals new hybrid car. Now let's utilize the toString method on these 4 objects to see the effects of polymorphism. We can see car make is printed to the console when the toString method is executed through the car1 object. That is because we never changed the form or type of the car1 object. It remained an object of the vehicle type. However, we changed the type of the car2, car3, and car4 objects, and therefore the toString methods called on each of these objects depends on the type each of the objects morphed into. So since we morphed car2 from the vehicle type to the fast car type, fast car is printed to the console when the toString method is called on this object, since that is what the toString method of the fast car class is programmed to return. Similarly, eco car is printed to the console when the toString method is invoked on the car3 object, and hybrid car is printed to the console when the toString method is invoked on the car4 object. Now notice we can continue to morph one of these objects into another form or type. For example, we'll move this println statement here, delete the rest of these println statements, and instead continue to morph the car2 object. So we'll morph it into an object of the eco car type, then we'll add another println statement after to see this change, then we'll morph it once more into an object of the hybrid car type, and once again add another println statement after this morph. When we run the program, we could see that the car2 object took the form of a fast car object, then took the form of an eco car object, and lastly the form of a hybrid car object. And this, the ability for an object of one type to assume the form of another type, is polymorphism. Keep in mind this is all possible through inheritance, meaning if any of the 3 classes, fast car, eco car, or hybrid car, do not inherit from the vehicle class, the initial object of the vehicle type will not be able to take the form of an object of any class that is not a child class of the vehicle class, like such.